Rendering scenes in 3D programs is a lot like when you're working with film in the real world or with photography. You obviously need lights, and in our case, we need to build scenes together with texturing, mapping, and all that, lights, and cameras, of course. So, in this video, we're going to talk about the basics of camera creation and manipulation in Maya. So, by default, you already have worked with cameras because you have seen scenes, you have been working with scenes. If I go to my four panel view, to my four viewport view, you see that basically we have four cameras in our default scene. Let me turn off this display thing for just a second. Okay, so now we see this is the top view camera, this is the front view camera, this is the side view camera, and this is our perspective camera. Now our perspective camera is the one that parallels the way real life cameras work the most. So if I go ahead and focus on that one, we can orbit around the camera, and when we're orbiting this way, we're actually orbiting the perspective camera. You see down here, the camera has a name. I can truck in by using my middle mouse button, and I can pan around by pressing the middle mouse button and the Alt key together to go ahead and pan around, pan left, pan right, or up or down, or truck in like we've seen in class. So you have the ability to control those cameras. This is pretty much something that you have been doing since you started modeling in class. What you didn't know is that the perspective view is an actual camera. As a matter of fact, if you look at your outliner, you see the default camera set up in your scene. By default, you have these four cameras. Now, if you want to create your own cameras, you can follow one of two workflows. You can go into Create Cameras, and you have several options for cameras, or you can go to your rendering shelf, and then from here, select to create a camera from here, which is this one right here. The default camera is a free, a one node camera is what we call it, or free flowing cameras like a handheld camera. So let me go onto the drop down here so we can talk about them really quick. We have one node or free flowing cameras, two node cameras, which is the camera and a focal point, a point where the camera is always pointing to. And then the third option is a camera, a focal point, and a way of handling the camera so that it's always that you can control the rotation of the camera, so the camera is always pointing upward in the proper way. So if you're aiming to create to attach a camera to a roller coaster or something like that, this would be one way to control it. You also have other types of cameras such as stereo camera, multi-stereo rigs, and we're going to be talking about those in the near future. So for now, let's just create a simple camera. When I create a simple camera, it comes in at the origin of the world. And as you can see, it takes the shape of a camera. Let me move that up a little bit and out and back this way. And let me zoom out from my perspective viewport. So as you can see, I have the shape of a camera in here. Now this camera it comes in usually at a regular size of 1 unit, just like if you were creating any other object. The reason why it looks so big in my scene is because my scene is fairly small. So, but you can always scale it down if it's getting on the way of the scene. You can always treat it just like any object. You can select it and use the R key to call the scale tool, and you can scale the shape. This will not affect what your camera is seeing, by the way. So scaling it is not going to affect the way the camera sees the world. Now, that camera right there is useful because we can place it wherever we want. We can animate it, and it can behave like any other object on the scene, which means I can animate it. I can attach it to another object if I want to control it through another object, and so on. So cameras are extremely useful. It is common practice to have several cameras within a scene in order to generate different angles of view within your particular scene. Now, with that said, let me go ahead and change my viewport from the perspective viewport to that camera. First things first, when I created that camera, a node was created that gives me access to the attributes of that camera, including the name. So if I wanted to change the camera name, I could go into Camera 1 to the Camera 1 tab and change the name to, say, for example, Close-Up Cam, something like that. If I hit return, then that changes the name of the camera. Over here on the outliner, you see that the name has been changed, and the shape controller for the actual node that controls the camera has also changed to showcase that the name has changed. So I can go ahead and name my cameras as I need. It is good practice to name, as with everything else that we have been seeing in Maya. It is good practice to name your nodes, because even though the program gives you node naming sequentially, eventually, say you have 15 cameras, it's going to be hard to figure out which one's which. So you want to give names to everything that you create that corresponds to the use of that particular piece within your scene. So in order to change my viewport from the perspective viewport to that camera viewport, I can go ahead and go into the panels drop down for that viewport, for the perspective viewport or any viewport. And from the perspective drop down, I can find the cameras that I have created. In this case, the CU camera is the one that I'm going to be looking at the world through. So when I switch it, you notice that I'm looking towards the wall, and on top of the little wagon. So if I truck by using my middle mouse button, I can see that I am actually moving the camera. Now, let me go ahead and switch my viewports to the 4-view. So you can see that when I am trucking on my close-up camera here, my camera is moving here on the top viewport. So I am controlling that, again, trucking through by using the middle mouse button, trucking in and out of the scene. And if I go ahead and press the Alt key and orbit, you will notice that my camera gets updated as well on those viewports. So the same way that I navigate the perspective viewport will respond, my camera will respond the exact same way any camera that you create, as long as you're looking through it. It allows you to do that. You of course have the option to select it on a different viewport and change the attributes of that camera for position, rotation, and so on. And the viewport will be updated over here because you're controlling the object. So you have the ability to control it both ways. So not much different there than with respect to the actual camera, the way we have handled the perspective viewport. So let me go ahead and focus on this one again. And let's talk about the attributes of the camera on the node. So the first thing that we see is that we have a drop down to switch amongst different cameras. Right now we have the option to choose, because we chose a regular camera, we have the option to choose one of the top 3 cameras. Camera, which is the one node camera, meaning I can handhold it. It's like a handheld camera. Camera and aim, which is if it has a focal point, basically the camera is pointing to a point on the scene, and we can control both, by the way. We can control the camera and the point to which it is pointing. And the camera aim and up, which allows me to control the how the camera is standing on the scene. So basically it's like a camera and aim with a pointing to something, but it allows me to maintain my camera pointing up or change the position of the camera based on however it's moving. I can maintain it always in a specific standing position. So that's where I can switch my camera. I can switch my camera to any of those. The most important things in cameras when it comes to rendering scenes are determined by these 2 settings here. This is your angle of view, which is how wide is the amount that you see on your screen or in the camera view, versus the focal length, which is the distance between an object and between the camera and an object that is in focus on your scene. So the distance between an object and the camera, it's the distance at which the camera will have things in focus based on the distance on the actual lens. So 35 millimeter is a standard size. If you have taken photography classes, you would know what that means. But basically it's just the size of the lens. And so the smaller the size of the lens, the wider your angle of view will be, giving you distortion such as a fish-eye lens. The higher your focal length, the longer your lens will be, the narrower your angle of view will be. If you want to create depth of field, you want to have higher focal lengths. So anything past 75 millimeters will work well for creating depth of field. If you go below 24 millimeters on the focal length, you're going to get a distortion. You're going to start getting fisheye distortion on your lens. So let's actually take a look at that and see what that looks like. Let me go ahead and make this actually 12. I'm going to go down to 12, and you'll notice that it looks like my lens just got pulled away. In reality, the camera hasn't changed position. It's just the focal length got it gave me a wider angle of view because my focal length is smaller. So if I want to return to where I was a second ago, I'll truck in, and that will cause my scene to get fish-eyed. Basically, I'm getting that distortion. So if I rotate, you'll notice that my scene is being distorted. Now, if I go ahead and pull back out this way, and then go ahead and change that focal length to say 50, then I am getting a regular non-distorted version of the scene. If I go higher than that, let's say I go to 100, then I'm getting really close. And what's happening now is that because I have everything set up inside a room, let me actually zoom out, make that 50. You'll notice that basically I'm getting cut off because my camera's already outside. That's how far I had to go in order to be able to get the proper. Let me go ahead and pull out this way significantly, try to aim that to the center and go to 100 again. And you'll notice that it looks like I'm zooming in, but I'm not. I'm really just changing the size of my lens. So basically just my natural lens is gonna be catching less of an angle of view. As you can see, my angle of view gets reduced every time I increase that, or if I go wide, then my angle of view increases. So that's how that's controlled. Okay. You can also control the scale of the actual camera overall by increasing the camera scale. I seldom do this. I try to control this by using only angle of view and focal length, because this is very unique to 3D worlds. And I try to mimic what I do in the real world when I'm working with my DSLR camera, for example. So then we have something called near clip and far clip. This far clip is basically these two things are the distance at which the camera will be rendering anything. So anything that is within 0.1 distance of the camera and 10,000 units of the camera will get rendered. Let me change this value here to, let's say, 150, or actually 50. Let me just change it to a very small value. As I pull out, as I truck out, you'll notice that the scene seems to get cut off. You guys see that? That means that that's as far as my camera is rendering. Anything that gets past that point will not be rendered. Anything between 0.1 and 50 units will be rendered. Let me make that a little bit more evident. Let me make it 20, and you'll notice that as I truck in, my camera seems to get cut off. So those are my clipping points on my camera. I usually just keep that at a really high value, like 10,000 or 100,000, so that I know that this is going to render appropriately no matter what. But you have control over how far into the scene. Suppose you have some stuff back there that you have modeled but you don't want to render, that would be one way to cut it off. Now, frustum refers to the ability for us to see the actual box of distance. So let me go ahead and display the frustum here, and let me switch my viewport to a different viewport. Let me go to my top viewport and select the camera. Now you see those green lights that are spilling out of the camera? That's basically the frustum. Basically, that's indicating the pyramid distance between the camera and the near or far clipping values. So let me make that 20. You'll notice that my pyramid shape got shortened because that's as far as my camera is going to reach. If I change this one, say to 10, you'll notice that basically my near clipping actually gets pushed in. So I'm actually cutting from the front. So honestly, seldom do I change these values, but they're there for a reason. They're there for you to actually, use in case it's needed within your scene. Now, I usually don't like to keep that display on, so I turn it off. And by default, it is off, by the way. Now, below this, we have the film back, which refers to the way the actual camera parallels film cameras in the real world. So let me go ahead and select the camera again. You'll notice that you have the ability to change based on presets. So you can go ahead and change the values of how your camera will see the world, how it will render the world based on apertures and focal lengths that are standard. So if I say super 16 millimeter, this is basically what that means. Let's scroll up and see what that did to our focal length. Basically, that changes those values there. So they are all tied to one another. Say, for example, we have 35. You'll notice that my values for angle of view and focal length change. And as you can see, these are all presets. So you can choose one of those if you're matching a specific project. But if you're trying your own project, you can always go back to user and change your values to your liking. Now, camera aperture over here, it's basically how much aperture you have in order to control the light that's going into the camera. And you can change it either via inches or via millimeters. And those values, basically everything's controlled just like you would be controlling a real life lens. You can change the aspect ratio of the camera. And to better see this, we want to activate in our camera. When we're working with actual cameras, we want to go to the viewport and activate under camera settings. We want to change the film gate. And we also might want to change other things or activate other things such as title safe and so on. Basically, title safe indicates anything that is text should be within this rectangle here. Anything outside might get cut off. Everything that's grayed out here will definitely not be rendered. Anything that is the live area, which is in here, that is your safe area for a camera. So anything that's moving should be within this big rectangle. Anything that is text-based should be inside that rectangle. Everything else outside might or might not get cut off depending on how the camera is moving. So you have the ability to set all those things up. Let me turn off the title safe really quick. And I usually just maintain, when I'm working with cameras, either the film gate or the resolution gate. Now my resolution gate is going to give me a frame that's based on the sizing of my render. So right now my default setting is 960 by 540. So if you change that to 720 by 480 or something like that, or 600 by 400, it's going to change to 3 by 4, or let's say 1920 by 1080. That might be 16 to 9, depending on the aspect ratio of your camera. And that is the area that will be rendered if we were to choose to render this way through the images when we go render in our rendering settings. Now, I can also go ahead and change the aspect ratio from in here if I want to. I maintain these values as default, to be honest with you, including the lens squeeze ratio. The only time I change this and the film aspect ratio, honestly, is when I'm working with anamorphic films. So if I'm going to be sending something to film and it's anamorphic, then I can go ahead and change this based on the values that I'm trying to match on the particular scene that is being created. So as you can see, if I keep on digging down, basically I'm seeing all the things that you would see on an actual film camera. For our purposes in class, most likely we will not touch any of these. The things that we will probably be working with will be the settings up here under the camera attributes. That'll be most likely enough for what we're doing in class, except perhaps for the film gate if there's something that we want to output to film. Now, there's also options for depth of field, and I am going to be creating a separate video for that. And there's also options for creating image planes based on the camera. So if you want to have an image that is always being seen by my camera, no matter how I rotate it or how I move it, then you would use an image plane, and that image plane will be controlled by the position of the camera. Let me go ahead and delete this background really quick, and I'm going to select the camera once again. And under that environment, I am going to create an image plane, and I am going to add an image to it. Let me go ahead and just choose this really quick, and I'm going to use an engine. I'm going to add that image, and as you can see, when I orbit my camera, the image doesn't change. My scene is being rotated, but the image does not change. Let me go to my 4 view, and you'll notice here that as I rotate, if I rotate my camera here, let me go ahead and rotate the view, you will notice that, let me zoom out far enough, you'll see that the image is there, and it will rotate along with the camera as I orbit my camera. So you have the ability to play something, say you want to try to match a model to the position of a camera on the scene, then you can go ahead and orbit your camera around until you match, and then you can do a render sort of trying to create, placing that 3D model into your scene. For that, you would obviously use lighting via SkyDome and projecting HDRI lighting into your scene.